Hey, what's up, SM3? We're going to be going over 8.3 this week. Um, so in this video, we're kind of going to combine what we went over in 8.1 and 8.2. Now, in 8.1, if you remember, we talked about SOHCAHTOA, which was sine, cosine, and tangent. Sine was opposite over adjacent. Cosine was adjacent over hypotenuse. Sorry, opposite over hypotenuse. Adjacent over hypotenuse, and opposite over adjacent. So we used the six trigonometric functions, the other three being the inverse, which was cosecant, secant, and cotangent. These were the six trigonometric functions, and we applied them to angles like that were less than 90, right? We applied them to angles that were between 0 and 90 degrees. Now we're going to talk about using these six trigonometric functions with any angle. Okay? So if you remember that we in 8.2 talked about the initial side of an angle on a coordinate plane and the terminal side. And the terminal side is the side that rotates, so this could rotate between 0 and 360 and so on and so forth, and it can be negative as well. So we're going to learn how to apply the six trigonometric functions with any angle upon the coordinate plane. So if you notice that since we are on a coordinate plane, now we don't have so far we haven't had it marked, but a coordinate plane of course has values. So we have positive x values, we have positive y values, we have negative x values, we have negative y values. So we could be at 1, 2, 3, 4, 5 on the x, up to 5 or more on the y. We could go in the negative direction and in the negative y direction, okay? And so this is how we determine the side lengths of our angle, or of our, I guess not of our angle, but of our initial and terminal sides, or of our terminal sides anyway. So for instance, let's say we had an angle at maybe we say 120 degrees. So this is our terminal side and it's rotated about 120 degrees. Now in this circle right here, the circle and this our terminal side intersect at a point. And that point, if we draw a line down from that point, then we have a right triangle. So if we have a right triangle here, so this right here is theta. This is the angle that we rotated. And now we have a right triangle from that right there. Now this distance right here is called x. This is how much on the x-axis we go until this side right here, this right triangle. And then of course we have the y direction, so how far up from the x to the intersection on the and where they intersect, the terminal side and the circle intersect. Okay. Now the hypotenuse, the length of the hypotenuse we call r, and we call it r because r is the radius of this circle. So r is the radius of the circle, and r is consistent, right? So no matter where you have your intersection of your terminal side and the circle, this distance is r. And so r is always going to be the hypotenuse. So we could have our terminal side over here. We could have rotated about this many degrees, and so then from here to here we make our line and draw our right triangle, and this would be r, this would be x, and this would be y. Okay? So that leads us down here to generalizing the trig functions of any angle that is on a coordinate plane. So we're going to let theta be an angle in standard position. So standard position means that our vertex of our angle is at the origin, if you remember that. Let x and y be the point where the terminal side of theta intersects with the circle. And specifically intersects with the circle x squared plus y squared is equal to r squared. This right here is just the equation for the circle. The equation for this circle right here. Okay, and the 6 trigonomic functions are defined as follows. So on this over here, so this is theta. Now we just read it as if like right here. We call even though this is theta right here, now the right triangle it makes comes from this angle. So theta makes this right triangle. So sine would be opposite. This would be the hypotenuse, and this would be adjacent. Except we're not going to use O, A, and H anymore. We're going to use Y, X, and R. Okay, so sine of this angle would be Y divided by R. So in general, we could define that for any angle. So that could be an angle that rotates all the way over here, twice around, and over here. So sine can be defined as the y direction over r, which is the radius or the hypotenuse. Cosine of this angle would be the adjacent side, which would be our x direction, so the length right here, which is x, and then divided by r. So cosine of theta would be x over r. Tangent would be the opposite y over x, which is the adjacent. And notice also that r is always going to be a number not 0, because we always have a radius. No matter where on this circle we're going to have a radius. Now that can't be said, let's say if our point right here, if we just draw the terminal straight up from right here, this creates a 90-degree angle. Now we'll talk about this later, but the x direction, this creates a right angle right here, but doesn't create a right triangle because it's just straight up. And so what that means is that my radius is equal to r here. Y would be equal to whatever y is, but x has no dimension, so x has no width. It's just going straight up. So x in this case would be equal to 0. Now the problem here is that means we have a 0 in our denominator. So we make sure and that we distinguish by saying that x cannot equal 0. Okay? And we'll go over an example on specifically how that looks. And then here we just have the opposites, the inverse, right? So cosecant would be the inverse of sine. So this would be r over y, but y cannot equal 0. And then again we have the inverse of r over x, and x cannot equal 0. Here we have x over y, and y cannot equal 0. So again, we don't say over here like r cannot equal 0. We don't say something like that, because r will never equal 0, because no matter where on this graph, the radius will always won't be 0. If it is 0, then you have no circle, which means you do not intersect. Your terminal side does not intersect with the terminal side, and the circle don't intersect because there is no circle if your radius is 0. Okay, so let's look at an example of what it means to find and evaluate the trigonomic functions given a point. So it says let negative 4, 3 be a point on the terminal side of an angle theta in standard position. So that's what we have here. We have our terminal side, and negative 4, 3 is the point that lies on the terminal side. So it creates a circle from that point. Evaluate the 6 trigonomic functions of theta. So we know, since this is negative 4 is x, 3 is y. So that means we had to go over negative 4 units, and we had to go up 3 units. Now this is our radius of our circle right here. Now we need to find the value of r. So r is our hypotenuse. So we just need to use the Pythagorean theorem to solve for the radius. So we know that we know the Pythagorean theorem. I'll write it off to the side here, which is, if we're going to use the same variables as we're using here, we could say that x squared plus y squared is equal to r squared. And then if I take the square root of both sides, I'll get r is equal to the square root of x squared plus y squared. So this is how I solve for r. So in this case, r is equal to the square root of x squared. So my x is negative 4. So negative 4 squared plus y squared, which is 3. And this is equal to the square root of 16 plus 9, and that's equal to the square root of 25, and that's equal to 5. So my radius is 5. Now for me, it helps me to just write these out. I know that my x is equal to negative 4. I know my y is equal to 3, and my r is equal to 5. Now this helps me because now I just have to write these 6 trigonomic functions. I know what y, x, and r is. So for sine of theta, it's y over r. My y is 3. My r is 5. For cosine, my x is negative 4, my r is 5. For tangent, my y is 3, and my x is negative 4. For cosecant, just flip them, so this is 5 over 3, this is 5 over negative 4, and this is negative 4 over 3. And there you go. Simply put, we have our 6 trigonomic functions here. Alright, so let's move on. Now, if you guys remember last time, we briefly, at the end of class, talked about reference angles. So let's review what a reference angle was. A reference angle, if I use this as an example, up here, so reference angle, so even this right here is what we call our angle right here. And that's the angle that's created from the initial side to the terminal side. So this is the angle created from the initial side to the terminal side. The reference angle is the angle from the terminal side to the x-axis. So this right here would be our reference angle. And we denote reference angle as theta with a little dash mark above it. So this is how we talk about our reference angle, or denote the reference angle. So right here, this is some easy ways to help you find the reference angle. So again, here is the angle created from the initial side to our terminal side, and this right here is our reference side, or our reference angle. So if you notice here, this angle in total is 180 degrees. However, if I subtract this portion right here, this leaves me with my reference angle. So that's how we could find, the reference angle. This is if the terminal side lies in quadrant 2. So if the terminal side lies in quadrant 2, then my reference angle can be found by taking 180 degrees. So we can say the reference angle when in quadrant 2 is equal to 180 degrees subtract theta. And theta is the terminal angle, where the terminal angle rotated. And in radians, the reference angle is equivalent to, we know that 180 is equal to pi radians, and then we can subtract theta. Here, so what we notice here is that this extends beyond 180 degrees. Okay, so for this one, to find the reference angle, so the reference angle in degrees and radians is equal to theta minus 180 degrees. Theta minus 180 degrees. And then, so the reason why that is because here is theta in its entirety. And if we subtract 180 degrees from theta, then we'll be left with the reference angle. So we take theta in its entirety, subtract 180 degrees, and we'll be left with the reference angle. And so in radians, it's the same thing, but we subtract pi radians. And then over here, so that was if it's in quadrant 3. If it's in quadrant 4, if our terminal side is in quadrant 4, so here is our angle for the terminal side. Now if I take 360 degrees, so this is 360 degrees, and if I subtract 360 from this, from 360, if I subtract pretty much the terminal side angle, then I will be left with my reference angle. So in degrees, just take 360, subtract theta, and excuse me, so yeah, so theta, I already have it written down here, so this is the reference angle, so this is equivalent to 360 degrees minus theta, and so 360 in terms of radians is 2 pi and minus theta, and this will give us our reference angle. So this is for cases where the terminal side is in the 4th quadrant. So let's do some examples here. So find the reference angle theta, or theta prime. I believe that's how they call this, theta prime. That's probably how I'm going to call it. Find the reference angle for A. So let's find A when theta is equivalent to 5 pi divided by 3. Now let's think about which quadrant 5 pi over 3 is. Now if we remember, we talked about last time, so pi is 180 degrees. So if I have my angle, this is 180 degrees. Okay. Now it's being split up into thirds, so that's going to be 1 So there's my thirds right there. Okay? Probably doesn't look quite proportional. Probably isn't. I can try to do a little bit better. So let's try that. Try that. Okay, so here's my thirds. And I'm going to make one more. Okay? But you can see here, maybe even one more. So this is pi. So I'm looking to go 5 pi over 3. So this would be 1 pi over 3. This would be 2 pi over 3. 3 pi over 3. 4 pi over 3. And 5 pi over 3. Okay? So that means that this is going to be in quadrant 4. So I know that this will be in quadrant 4. Okay? So knowing that, I know that I could take, we're in radians, right? So I can take 2 pi and I can subtract 5 pi over 3. So I can take 2 pi. So my reference angle would be equal to 2 pi minus 5 pi divided by 3. So this is over 1, so if I want to subtract these, I need to have a common denominator. So this would be equivalent to 6 pi over 3 minus 5 pi over 3. And that would be equal to 6 minus 5 would be 1 pi over 3. So this is my reference angle. So pretty much my reference angle in this case would be this angle right here. It's the angle from the terminal side to the x-axis. Alright. Now for B, my theta is equal to negative 130 degrees. So if I were to draw this angle, here's my terminal side. So it's going to rotate 90 degrees, and this is negative 180. So I know I'm between here. And so I know that I'm just somewhere in quadrant 3, which is really all I need to know. So because I'm in quadrant 3, I can take my angle and subtract 180 degrees from it to find my reference angle. So my reference angle is equal to theta minus 180. My theta in this case is negative 130 degrees. And then here I can subtract 180 degrees from that. And so this would equal so let me punch that into my calculator really quickly. So if I take 130 subtract 180, I get 310. Negative 310. Oh, sorry. I also failed to mention that this is whenever we're going in the positive direction. I need to make sure I distinguish that. So here we're going in the positive direction, but in those cases we're going the positive. But this was going in the negative direction. So in that case, excuse me, I want to take 130 and I want to add 180 because again we're working in the opposite direction. Sorry, because your reference angle has to be less than 90 degrees, so that's why I was a little bit confused there. But yeah, because we're working in the opposite direction, so negative, I want to add 180 degrees. So I will take negative 130 and add 180, and I get 50 degrees. So this angle right here is going to be 50 degrees. So that is my reference angle. Okay. So yeah, just note that if you ever get a number larger than 90, then you probably got your reference angle wrong. Okay. Now these are just tips. You don't have to follow these. To be honest, I don't like following these. I think it makes more sense to just kind of think about it and solve it from there. But if it helps, go for it. Now, the reason why we have these reference angles is because reference angles allows us to evaluate trigonomic functions for any angle. Now, it might change depending on the quadrant. The sign of our value might change, but that's something that we can figure out on separately. So my point being here, so let's say I have two different angles. So here's an angle, and this is 45 degrees. So let's say theta here is equal to 45 degrees. Now let's say I have another angle over here, and let's say that this is 225 degrees. Okay, now let's make our circle. Pretty much, let's just take this line. Let's just draw our line that connects from right there. Let's make a right triangle out of both of these right here. Okay, so we make right triangles here. Now, the reference angle here is 45 degrees. But we'll just note that for just a second. But let's say for here, if I find sine of 45 degrees. Now this is a special triangle, right? So if it's a special triangle with 45, 45, that means this is 45, this is 90. That means the ratio is always 1 to 1 to the square root of 2. Similarly over here, if I do sine of 225, this makes a 45 degree angle down here, which means that this is 1, negative 1, this is negative 1. So again, in terms of the coordinate plane, these are negative because we went in the negative x and then negative y. And then this is square root of 2. So sine, on the left side, sine of 45 would be 1 over the square root of 2. And if you rationalize the denominator, it would be square root of 2 over 2. Now, over here, this would be equal to negative 1 over the square root of 2. So negative 1 over the square root of 2. And then if you rationalize the denominator, you have negative square root of 2 divided by 2. So notice here and here, you have essentially the same answer, just different signs. And that's because these angles, so if you have theta equal to 45 degrees or theta equal to 225 degrees, because this theta right here creates a reference angle of 45 degrees, then their values will end up just being the same, just with a different sign. So this one's negative and the one on the left is positive. So that's why we use reference angles, because we can it helps us identify in cases of special triangles anyways. All we need to know is really just the sign that changes. That changes in the answer. So down here, we're going to this is going to be a process to help us evaluate for the 6 trigonomic functions for any angle. So it doesn't matter if the angle is, it doesn't matter which quadrant it is in, this will help us in any case. So first, the step 1 is to find the reference angle. So find the reference angle. So notice up here, this is in quadrant 1. Quadrant 1 doesn't really have a reference angle. It is, what it is. First thing I did over here on the right side was I noticed that this was the reference angle was 45 degrees. Now, step 2 is to evaluate the trigonomic function. So evaluate the trig functions, or I guess we could just say the trig function. Excuse me, I'm messing up my writing. Evaluate the trig function for the reference angle. So up here, I evaluated the reference angle for theta, not for the reference angle, because I wanted to show you that they were just the same. So, but in general, whenever you're evaluating, just evaluate the trig function for the reference angle. And then step 3 is to determine the sign. Determine the sign of the trigonomic functions. Determine the sign of the trig functions depending on the quadrant. Depending on the quadrant that theta lies. So over here on the right side, so once you have those written down, pause it if you need to, but over here on the right side, this is where you can reference. So here, if it's in quadrant 1, if you have sine of theta, or if you have cosecant of theta, your sign should be positive. So your trigonomic function value will be positive. And that's because, like up here, your y and your x will be positive. So your y is positive and your radius is positive. So the sign will always be positive. Now, cosine of theta and secant of theta will also be positive. Tangent of theta, cotangent of theta will also be positive. On the left side, sine of theta, cosecant of theta will be positive, because again, y is still positive, and these are y over r. Cosine of theta, secant of theta will be negative, because our x is negative when we're in this quadrant. So I'm going to just write up here, this is positive y, this is negative x, this is negative y, this is positive x. So hopefully that helps you see why this is. And then here, tangent of theta, or cotangent of theta, this will be negative, because tangent includes x, which in this case would be negative. Over here in quadrant 3, sine of theta and cosecant of theta will be negative, because y is negative, and sine is y over r. Cosine of theta, secant of theta will also be negative because this involves x over r, and over here x is negative. And then tangent of theta and cotangent of theta will be positive because tangent is x over y, and here we have negative and negative, so that means we'll have negative divided by negative, which will be positive. And then in quadrant 4, sine of theta, cosecant of theta will be negative because sine is y over r and y is negative. Cosine of theta, secant of theta will be positive because cosine is x over r, and over here x is positive. And then tangent of theta, or cotangent of theta, will be negative because x over y, x is positive but y is negative. Okay, so this is how you can this is what you can refer to, the signs of trigonomic values. You can refer to this, so find your reference angle, evaluate the trig function for said reference angle, and then you can determine the value of the sign by using this. So let's put this into practice right here. So we have A, which is tangent of negative 240 degrees. So first of all, let's decide, we want to find the reference angle, right? So that's always the first step. So first step is to find the reference angle. So quickly, I'm just going to draw this angle. So if it's negative, so here I can move negative 90, negative 180, negative 270, which is too far, so negative 240 would be 30 degrees over this way, which means that my reference angle would have to be 60 degrees right here. So 60 degrees. So that's what we're interested in, 60 degrees. Now, for me, I'm just going to draw my angle right here. I'm just going to draw my right triangle. However, that was poorly done. So this right here would be my reference angle. I'm just drawing my right triangle if I were to make my right triangle right here. So this is my reference angle, which is 60 degrees. So I'm going to write that in. So my reference angle is equal to 60 degrees, which is a special triangle, right? It's a special triangle. Now I want to evaluate for tangent of 60 degrees now. So not negative 240, but I'm going to solve for tangent of 60 degrees. Okay, now for a 60-degree triangle, we need to understand that, remember the ratio. So square root of 2 is always the hypotenuse. So my hypotenuse will be square root of 2. My other possible side lengths are 1 and 3. Now, 60 degrees, this is a 30-degree angle. This is a 90-degree angle. Now, 60 degrees, so here if I have a right angle, and this is my terminal side, 60 degrees creates a longer side over here, right? So that means this side on the left will be longer. 30 degrees creates a shorter side, so the angle or the side opposite of 30 degrees will always be the smaller side. And I totally lied to you. Sorry, this should be square root of 3, I think. Square root of... Now I'm having trouble to remember. I'm pretty sure it's square root of no, this should be 2. I think I had it right. So 1, 2, square root of 3. I'm totally forgetting, guys. Sorry, let me go ahead and make sure my notes. I am drawing a blank. It is square root of 3. Okay, I knew something was up. So 1, 2, square root of 3, where 2 is the hypotenuse. That's where I was getting mixed up. 2 is always the hypotenuse. So this is 2. Now, opposite of this angle is going to be the larger of 1 and square root of 3. Now, square root of 3 is something like 1 point something. So this side is obviously larger. Okay, so that means that across from this angle should be the square root of 3. Across from 30 degrees should be 1. Alright, so now I want to find tangent of this angle. Tangent is opposite, or in this case, y over x. So then this is equal to the square root of 3 over 1, which is just equal to the square root of 3. Now the third step is that we need to make sure that we have the sign right. So if we come back over here, we did tangent of theta, which means that our sign should be, sorry, I'm in the wrong quadrant. We were in quadrant 2. So tangent of theta, our sign should be negative. So that means the value of this, the final value should be negative square root of 3. Now, if it helps you guys, just know that we are in the second quadrant, which means that this is actually negative, right? Because in our quadrant, this is negative x. So if that helps you, you can do it that way instead. But anyways, now let's try it for b over here. So we want to find cosecant of 17 pi over 6. So we're going to want to, if you want to, you feel better converting this, go for it. That being said, I'm just going to roll with it and see if I can find the angle. Okay, so here I know that my pi is being split into 6 parts, so which means 180 is being split into 6. So 180 divided by 6 is equivalent to 30 degrees. Okay. So once I split this up into 6 portions, so here's 1, here's 2, 3, 4, 5, and 6. Okay. Each of these are 30. And same with the other side is also split into 6. So what that means is here's 1, 2, 3, 4, 5, 6, and I need 17. So then this would be 12, 13, 14, 15, 16, 17 pi over 6. So again, if these are all 30, so this is 30, 30, 30, that's 90, plus 30, plus 30, this is 30 degrees. So my reference angle has to be 30 degrees. Or, if we're talking about radian measure, so 1, my reference angle is equal to 30 degrees, but we're using radians, that's the same thing as pi over 6. Because pi, which is 180 degrees into 6 parts, is 30 degrees. So pi 6 is my reference angle. So 2, what we want to do is to evaluate the function. So cosecant of pi over 6, and cosecant, if we remind ourselves, if we go back up here, cosecant is r, the radius over y. So the radius over y. And again, if you want to make your own triangle, I'll do that over here. So this is my reference angle, so this is 30 degrees. That means this is 60 degrees, this is 90. This is the angle created from here, by the way. So this creates, again, a 30, 60, 90 triangle where my hypotenuse, or R, is 2. Across from my 30 degree angle is the smaller side, which is 1. Across from the 90 degree angle is the larger side, which is square root of 3. And cosecant, like we said, is R over Y. So in this case, R is 2 divided by Y. And so in this case, Y is 1. So it's just equal to 2. Third is to, so we're in quadrant 2. So let's identify the sign. So cosecant right here in quadrant 2 is always positive. So in this case, it just stays as 2. So cosecant of 17 pi over 6, which is the same thing as the cosecant of pi over 6, is equal to 2. Okay, and there you go. Now, this we might not get to all the way in class. We might leave it for the next video. I'm going to cover it now anyways, just so we can get it done, and just expect that the next video will probably go into this a little bit more in depth. But we're going to talk about the unit circle. So the unit circle, if you notice here, this looks exactly like, pretty much exactly like the figures that we used up here. The unit circle is this same figure, but specifically our radius of our circle is 1. So the radius of the circle here is equal to 1. Okay? So the circle x squared plus y squared is equal to 1 has the center at 0, 0, has a radius of 1, and this is called the unit circle. The values of sine theta and cosine theta are simply the y coordinate and x coordinate respectively of the point where the terminal side intersects. So here's the thing, that if r is equal to 1, sine of theta is y over r, but if r is 1, then sine of theta is just whatever the y coordinate is of this point right here. Whatever point this is, if r is equal to 1, then sine of theta is y. Cosine will just be x. So that's pretty much what the unit circle says. It's really not too difficult. So specifically here, this is helpful whenever we have an angle, or terminal side, that lies upon the axis, any axis. So if it's right here, this is a 90-degree angle. Over here, this is a 180-degree angle. This is 270-degree angle, and this right here is either 0 or 360-degree angle. Now, the thing about whenever we have an angle such as those, so for example here, theta is equal to 270. So this right here is 270 degrees, which puts us on the negative y-axis. This point is on our negative y-axis. Now remember, this is a unit circle, which means our radius is equal to 1. This point right here is 0, negative 1. So in the x direction, we don't move, and in the y direction, we go down 1. So basically, we can sum up our information as this. X is equal to 0. Y is equal to negative 1. R is equal to 1. The radius doesn't have a negative sign, so it's just always positive, and our radius is 1. And we want to find the 6 trigonomic functions. So we want to find sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. And good thing is we already know how to find these from this section right here. So if you have that handy, you can use that to solve these. So sine of theta is y divided by r, so negative 1 divided by 1, which is negative 1. Cosine is x over r. X is 0, so 0 over 1, which is equal to 0. Tangent of theta, which is y over x, so this would be negative 1 over 0, but this is 0 is in the denominator, so this is undefined. Cosecant of theta is the opposite of the fraction over there, so 1 over negative 1, which is still negative 1. Secant of theta would be 1 over 0, but we can't have 0, so this is undefined. Cotangent is x over y, which is equal to 0 over negative 1, which is just equal to 0. And that's pretty much how you can use the unit circle. Okay. Doesn't have to necessarily be points on this line, but that's how you could use it. Okay, so that should wrap it up for 8.3. I know it was kind of long, definitely dense. It has a lot of material, has a lot of content. So if you need to rewatch this video, please go ahead and do so. If not, you can see me in class and we can discuss it further. Thanks.